Right, graphing the standard form, okay? Ax squared plus bx plus c, as opposed to this form, okay? Right, now, what we need to do here, if we can't factor it, if we want to change this to look like this, all right, then we complete the square. So here's an example right here. Now, I actually do it a different way to how they're doing it. I'll just show you, if we're going to do it by completing the square, then look at this. Remember how we set up completing the square, okay? So if imagine this equal to 0, if we take away 23 from both sides, we'll end up looking like this, okay? Now then, how do we complete the square? What's half of 10? 5. What's 5 squared? It's 25. So I would add a 25 to this side, but don't forget to balance it by adding a 25 to the other side as well, okay? So I've got to add 25 to this side as well. Now, of course, this will give me positive 2 on this side. And remember what this means? This will give me x plus 5 all squared. Imagine I factor that into x plus 5 times x plus 5, okay? Now then, if I now bring this, now I'm going to solve this. If I bring the 2 back onto the left-hand side, I'm going to have x plus 5 all squared minus 2, okay? Now then, that is what they have down here, okay? So remember, so the vertex is going to be negative 5, negative 2. Okay, remember that from previously? The axis of symmetry is going to be x equals negative 5. Okay, and we have all the information down here. Okay? Right, so now look how they've done it. They've actually kept everything on the same side. So they've kind of separated this here, right? They've done what I've done and added the 25. But then on the same side, if you add a 25 to balance it, you need to take off a 25 because it's on the same side. So they've also put that there and still got the plus 23, which is the end term. So again, this will, of course, cancel if you wanted it to, right? But we don't want it to. We want to keep this first part, that bit there, okay? Remember, that becomes that. And negative 25 plus 23 at the end here, that's the negative 2 there. Okay, so it's up to you. I tend to like to throw it as though I was completing the square, put the number on the side, but don't forget to bring it back again, all right? So that's that. That's completing the square. So I've changed it to look like this. Whoops, I totally crossed it out. To look like that version there, okay? Let's look at some examples. Right, now, if I go back to, okay, this original one. So if it is x squared plus 10x plus 23, I don't actually have to graph it by using this technique of completing the square and change it to the form. I can actually do it as though it was something like this. So I'll graph something like this. But before we do this, there's a little shortcut to find the vertex. So again, when it's in this format, the vertex is the h and the k. You can see it in the question. Okay, remember, just change this sign. But when it's in this form, you can do a little trick. It's here. The vertex occurs at negative b over 2a. It's right here, okay? It comes from the quadratic equation formula. But negative b over 2a is the x-coordinate of the vertex. And once you've found it, if you put it back into the equation, it'll give you the equivalent y, okay? So you're going to find the xy coordinate of the vertex by doing negative b over 2a. Let's have a look at this. Right, okay, so let's look at this. If I do negative b over 2a, that's negative 14 over 2 lots of negative 1. 2 lots of negative 1 is negative 2. So the x-coordinate of the vertex, negative 14 over negative 2, is going to be 7. There it is. Okay, so find the vertex. Well, the x-coordinate is 7. I won't know what the y is until I put that 7 back into the equation where x is. So 7 squared is 49. Okay, with a negative in front, negative 49. 14 times 7, 98. Take away 47 at the end, you get 2. Okay, so that is the vertex. I found the x-coordinate by doing this, negative b over 2a. Then once I found it, I put it back into the equation to find the y-coordinate. Okay. Right, determine whether there's a maximum or a minimum at this. Okay, so this is going to be a negative x squared, so it's going to have a maximum. If I look down at the graph over here, there it is. Okay, there's the point. Is that 7, 2? Okay. So what else do we have? We have determine whether that's that one. Find the range. Now, if I look at this, the range of this is going to be, you can see it's going to go all the way down. So from negative infinity goes as high as whatever the y coordinate is, and that's 2. The 7's got nothing to do with it right now, okay? So it goes from negative infinity as far as positive 2. That's the range, which is right there, okay? Now then, where's it increasing and decreasing? Well, can you see it increases from negative infinity to 7. This is where the 7 comes in. There we go. And then it decreases from the 7 again to positive infinity, okay? Okay, left to right. So from negative infinity to 7, it's increasing, and from 7 to infinity, it's decreasing.